Okay, I would like to start with 21. Y equals x squared, and y equals the square root of x. So find the area, we have to graph it, we have to find points of intersection, and we have to shade it in, and then decide what to integrate, how to integrate, and so on and so forth. Okay. I chose a very simple example. This is a very simple situation because we know how to graph these functions. These are base functions for x squared. Here it is. As we know, this is y equals x squared. And we know how to graph this as well. Y equals the square root of x. Obviously, this is the area in question. I know that one point of intersection is at 0, but I don't know where the other point of intersection is. I have to set them equal to each other. So I will set x squared equals to the square root of x. Now we have to remember how to solve such an equation. This is radical. Anyone remembers how to solve a radical equation? What is the procedure? What do we need to apply? Anyone remembers?
You isolate the radical?
It is isolated. Isolated, it is. On one side alone. Correct. That would be the first step, but it's already done. I agree. What will be the second step? To eliminate the radical, how will I eliminate the radical? What should I do to both sides?
You raise it to the power of 2?
Exactly, of course. Good, so we have x to the fourth equals x. This is polynomial degree 4. I have to move x to the other side and factor out x. If you remember how to factor this binomial, this will be x minus 1 and x squared plus x plus 1. And we have an x in front. This has no real solutions. So the only solutions are x equals 0, which we already knew. So x equals 0 and x equals 1. So the area is enclosed between 0 and 1. So now we know, in order to find the area, we will have to integrate from 0 to 1. From the upper minus lower. So the area is the integral from 0 to 1 from the upper square root of x minus lower dx. A very simple situation. So let's integrate. Remember, we have to replace this by x to 1/2. So it's x to 3/2 over 3/2 minus x to the third over 3 from 0 to 1. I always love having 0 as the lower limit, because when I plug in 1, I get 2/3 minus 1/3, which is 1/3, and when I plug in 0, I get 0. So I flip, I get 2/3 and minus 1/3. And this is 1 and 1. And when I plug in 0, this is 0, 0. So this is it. Any questions before we choose the next one? Any questions? Okay, let's choose another. Some of the graphs are more involving. anyone would like to choose? If not, I will.
What books could you choose?
15 through 33.
Because we're 5.
I'm sorry, you said 25?
Yes.
Very good. So 25 appears to be another straightforward situation. In 25, we have y equals 5, y equals the square root of x, and x equals 0. Very good pick, I think. So, of course, we have to graph. Again, we have the square root of x, which is nice. We have x equals 0, which is this. And we have y equals 5. 1, 2, 3, 4, 5. So y equals 5. I may have to adjust the graph because I need to make sure that at some point in time, the function eventually will cross 5. How do I know? Well, the square root of x equals 5. When I square both sides, x equals 25. So I have to regraph because the intersection is somewhere and I don't want to adjust that graph. I will graph it again. So 5, 10, 15, 20, 25. And here is 1, 2, 3, 4, 5. Y equals 5. So this is the point of intersection. So this is x equals 0. This is y equals 5. I already have it there. And this is the function y equals the square root of x. So obviously this is the area in question. So the area will be the integral from, of course, 0 to 25, from the upper minus the lower. So what we did first, we graphed, we were given 3 curves this time. We were given x equals 0, which is the y-axis, y equals 5, which is this, and y equals the square root of x, which is the radical function, the square root. After we shaded, after we graphed, we realized that the area that touches all 3 curves is this. So now we know that the area is obtained from 0 to 25, and from the upper minus the lower. Upper function is 5, lower function is the square root of x. Okay, so now let's calculate. Uh, 5x minus, remember this is x to 1/2, so x to 3/2 over 3/2 from 0 to 25. I always like, as I said, 0 is the lower limit or the upper limit. Makes it so much easier. So 5 times 25, 125, minus 2/3. When I plug in here 25, the square root of 25 is 5. 5 to the third is 125. Minus when I plug in 0, but this is 0, this is 0. Okay, so what I would like to do now is factor out 125, and then I have 1 minus 2/3, which is 1/3. So the answer is 125 over 3. Any questions? Any questions?
Can you go over how you pulled everything from the graph you made?
So I graphed y equals 5. I graphed x equals 0. And then I graphed the square root of x. And I know that eventually, when I set these two equal to each other, the square root of x with 5, I know that there is a point of intersection. I squared both sides, and I got x equals 25. Because I need to determine the points of intersection, I have to have a lower limit for the integral and the upper limit for the integral. So that's why the integral is between 0 and 25, from the upper minus lower. Was that the question?
Yes, thank you.
Is this better now?
Yes, and then from that you got the 0, the 25, and then the 5 minus.
From 0 to 25, from the upper, which is 5, minus the lower, which is the square root of x.
Thank you.
My pleasure. Was the rest of the calculation okay?
Yes.
Okay, perfect. Now, I also wanted, we're going to have more examples, of course, but I just wanted to show one formula, which is the average value of a continuous function on a comma b, a closed interval. So f average is 1 over b minus a, the integral from a to b from f of x dx. This is the formula. So if I have a function that is continuous on this interval, and if I'm asked to find, or I want to find the average value of this function on this interval, all I have to do is determine the definite integral from a to b from f of x dx and divide by 1 over b minus a. So let's look at a couple of examples and then come back to anything else. So here it is. Find the average function value, the average value of a function over the given interval from 34 through 44.
$37.
37, very good. So in 37, we're given the function which is e to negative x, and the interval is 0, 1. And they're asking us to find the function value, the average function value. F average is 1 over b minus a, but 1 minus 0 is 1. I don't have to write anything. The integral from 0 to 1, e to negative x dx. And remember, the antiderivative of this is e to negative x over negative 1 from 0 to 1. It's better to write it first as negative 1 over e to the x. Negative 1 in front, e to negative x is 1 over e to the x from 0 to 1. And careful now. Leave the negative sign outside. When I plug in 1, I have 1 over e. Minus, careful, when I plug in 0, e to 0 is 1. 1 over 1 is 1. And now distribute the negative sign. So I get 1 minus 1 over e. 1 minus 1 over e, and you have to leave it alone. Yes, you can approximate it if the problem is asking us to approximate it, but 1 minus 1 over e is 1 minus 1 over e. That's the exact. What is this? It's the average value of this function on the given interval 0, 1. If this function were, let's say, the velocity function, this answer would be my average velocity between Baltimore and New York. This would be the average velocity. Good. We have time for another. Another average value. Anyone would like to choose another? No one? Should I choose? Okay, I will choose 43. So the function is 3 divided by x squared, and the interval is 1 to 5. Okay, so f average is the integral from first 5 minus 1, 1/4 in front, the integral from 1 to 5, from 3 over x squared dx. So the formula is, again, function value is 1 over 5b minus a. 5 minus 1 is 4, so it's 1/4 in front. The integral from 1 to 5 from f of x dx. Now I have to find, I'll leave 1/4 alone. I have to find the antiderivative of this. Well, when I differentiate -3 over x, maybe I should just explain this one more time. Remember when we differentiated 1 over x? We said that this is -1 over x squared. This was a long time ago. Now, if I multiply both sides by -1, and I integrate 1 over x squared, this is what I get. I get -1 over x. So when I integrate 1 over x squared dx, I get -1 over x plus a constant c. Because when I differentiate this, I get 1 over x squared. And when I differentiate the constant, I get 0. So 3 is 3. I could have put it outside. We could have written this from the very beginning. Maybe that's even easier for you to understand. So 3/4 can stay outside. But the integral of 1 over x squared is -1 over x. So -3/4. When I plug in 5, I get 1/5 minus when I plug in 1. So the final answer, -3/4, and this is multiplied by -4/5. 1/5 minus 1 is -4/5. Of course, I will simplify, multiply the negatives, so the answer is 3/5. That's the average value of this function on the interval 1, 5. So it is very important to understand this, because otherwise another option is to change this into 3 times x to -2. And you'll get to the same answer. That will be the other answer, right? So the integral from 1 over x squared dx can be changed into x to -2 dx, and then you have x to -1 over -1 plus a constant c, and you get to the same thing. -1 over x plus c. It's up to you. This is okay, this is okay. But this is less work than this. But of course, you use the method that makes you comfortable. That's the most important. Any questions? It's a lot of work depending with these integrals, depending on functions. And on Thursday, I would like us to go back to looking at other functions and finding the area among curves here. So we're going to start here with, another example or two. Many of them require a lot of work